Black holes are one of the many things that lie in our universe. Even though we know that they exist and are out there, we aren't able to see them lurking around in space. We are only able to detect them through the effect that they have on their surroundings. I asked 4 Fresno State University students 5 questions regarding black holes to learn their general knowledge on them. I then asked astronomy professor and Downing Planetarium director Stephen White for his input regarding the questions. The first question that I asked them was, what is a black hole?
It should be a body in space with no mass.
Something in space where everything disappears, it falls into it.
I believe it's a star that disappears in space after its cycle.
A black hole is a star that has exploded and it eventually turns into a black hole, which it's just this large power of gravity pulling everything back into the middle.
A black hole is a gravitationally collapsed object. It's so dense with gravity so strong that not even light can get out. And if light can't get out, neither can anything else.
As Dr. White explained, a black hole is a gravitational collapsed object in space-time from which nothing, not even light, can escape. This is where the name black hole comes from. Because light is unable to escape it, its surroundings get engulfed in complete darkness. The next question was, can you see a black hole?
Yes, it should be pretty much like a black spot in the universe.
Yes, you can see a black hole.
I believe you don't.
You can see it because it's dark. It's supposed to suck in light, but because it sucks in light, you can spot where it is because it's just dark.
Unfortunately, astronomers are unable to see black holes directly due to them sucking in all of the light that surrounds them. However, astronomers are able to discover black holes from the effect that they have on their surroundings. One way they're able to detect a black hole is by using radio and X-ray telescopes. Using a radio telescope, astronomers can detect jets that are being spewed out by the black hole, even though the black hole itself appears invisible. The size of the jets depend on the black hole. The larger the black hole is, the larger the jets become. I then asked, how does a black hole work?
It should attract all the, other planets or things in space and shrink them up.
No, they don't, sorry.
No.
I'm not sure. It's just very, very strong gravity.
Well, the gravity is strong and it warps the space around it, and basically it curves the space so strongly that light then follows that curved orbit. Of course, any other material will follow the curved orbit around a black hole as well. And what they can do actually is, if there's matter nearby, you'll get an accretion disk around the black hole, and then that matter will grind and rub and heating to millions of degrees, producing X-rays. And if you're looking for black holes, that's probably the first thing to look for.
A black hole attracts anything that surrounds it. The black hole attracts things because at the center of it, there's a singularity, an infinitesimal point in space where the pull of gravity is extremely strong. The gravitational strength of a black hole causes light that surrounds it to be sucked in, which causes the black hole to be dark all around. The darkness that surrounds the black hole is called the event horizon. Once something reaches the event horizon, it can never get out. Here, we have a star that wandered too close to a black hole. My next question was, how is a black hole formed?
No, I don't.
Things disappear when they fall into it, but I don't know how it works.
No, I don't.
After a star dies, where it expands and then it is pretty much a supernova, but then eventually it starts coming back together again.
Well, there are a couple of ways. One way is when a giant star explodes, in a supernova explosion, if the core survives the explosion and collapses, and it happens to be more than 3 solar masses, then there's nothing in physics that can support it, and then gravity continues the collapse down into the black hole. There's another way too. If you have a lot of stars and gas and dust collected at the center of a galaxy, then all of those stars orbiting around the center, of course, they tend to run into each other, and then if enough of them fall in, it leads to something called a quasar, where you have a black hole, an accretion disk, lots of stuff going around that's going to produce a lot of energy. But you can find black holes, supermassive black holes with millions of solar masses at the centers of, we think, most large galaxies.
Here is a short clip explaining the birth of black holes.
This is the dying star, VY Canis Majoris. It's more than 1 billion miles across. Like all stars, it's a giant nuclear fusion reactor, pumping energy outward. At the same time, the star's extreme gravity crushes inward. For a few million years, fusion and gravity are locked in standoff. But when the star runs out of fuel, fusion stops, and the stalemate ends. Gravity wins. In a millisecond, the core shrinks to a fraction of its original size, and a baby black hole is born. Immediately, it starts to cannibalize what's left of the star. The new black hole in the middle keeps feeding on the body of the star around it. It eats the gas so fast, it chokes and coughs, blasting out huge beams of energy.
So basically, the star is dead before it hits the ground.
Finally, the star explodes. In 1 second, it blasts out 100 times more energy than our sun will produce over its entire life. What's left is a new black hole and 2 jets of energy hurtling through the universe at the speed of light.
My last question was, what is inside a black hole?
I'm not sure. I don't think anyone knows.
Nothing, because things disappear.
No.
No clue.
Well, that's hard to say. We don't have anything on Earth that can help us with the description. You have the event horizon, which basically is an imaginary surface which cuts the black hole off from the rest of the universe. And then down somewhere in the center of the event horizon, you'll have the stuff that makes the black hole. But what that stuff is like, it's hard to say.
Even though there are many theories about what lies at the center of black holes, theories ranging from nothing to alternate universes, the truth is that no one knows. However, most theoretical physicists are hard at work to find the answer, because they believe that once they have the answer to what lies inside a black hole, they might have the answer to one of science's biggest questions, how the Big Bang was formed. But as exciting as that may be, it might be years until we have an answer. However, what we do know is the history of black holes. Here is Dr. White talking about the history.
Once Einstein came out with general relativity, people started working with the equations, and Oppenheimer actually put out one of the first papers that suggested theoretical possibility of a black hole. Einstein didn't believe it, actually. He thought there'd be something in nature that would prevent the final collapse. And so people thought about it and argued about it for decades. But about 25 years ago, several astronomers were looking at X-ray sources in the sky. These X-ray sources would come and go, and at the time we didn't have good enough X-ray telescopes to pinpoint exactly where these things were, because ideally what you'd want to do is pinpoint the source of the X-rays and then look at it in other wavelengths, like in the optical. But eventually they were able to pinpoint an X-ray source, and then of course these things come and go. They generate a lot of X-rays, and then they start back up again. when it was quiet, they found the source and they saw basically something very interesting, a star racing around an empty point in space. Okay, that's interesting because if a star is orbiting a point in space, there has to be something at the center to attract it, to cause it to follow that sort of an orbit. And with a little bit of physics, you use Kepler's third law. Basically, what you need to do is measure the period. That's not so hard. You can see the star racing around. And you can measure the diameter of the orbit. Now, to do that, you need to measure the angular size as we see it, and you need to know how far away it is. But if you have those two pieces of information, then you can get the size of that orbit. And with those two pieces of information, the period and the size of the orbit, you put those into Kepler's third law, and you can calculate the mass of the thing that's attracting it at the center. And when they found something more than 3 solar masses, it was the first confirmed case of a black hole. And I believe that was in the constellation Cygnus.
Another interesting fact about black holes is their size. They could become massive. On December of 2011, astronomers discovered their biggest black hole yet. Here is a short clip about it.
Yeah, each one has the mass of about 10 billion times that of the sun. And we can also think about their sizes, that is to say the region of space within which light cannot even escape. And that size for these black holes are about 5 times that of our solar system.
As she explained, the new black holes that were discovered had an event horizon of 5 times our solar system. As you can see, the picture shows black hole in scale to our solar system. Black holes are very interesting things. The more we learn about them, the better we begin to understand our universe. We hope that once we understand them better, we will be able to discover new things about our universe.
Well, almost everybody's heard of a black hole, but a lot of people think they're just from science fiction. But it turns out, well, our universe is a lot weirder than you might expect, and black holes are real.